Now, let's do an example. In this diagram, PQRS is a parallelogram with ST equals to TR. As you can see, I've shown that ST is equals to TR. With SM equals to MQ. As you can see, I've shown there. Now, we are told to determine the ratio of the area of triangle MRT, the ratio of triangle MRT over the area of triangle MSR, MRS. We are told to find the ratio of the ratio of the area of triangle MRT over the area of triangle MRS. For us to do that, we need to first construct a height. I'm going to construct it in blue. Construct a height. There is a height which I've constructed, which is perpendicular to the base, TR, for MRT. Also, it is perpendicular to the base, SR, for triangle MRS. I'm not sure if there's some confusion there. If there is, we will try and explain that. Therefore, we construct our height since we are told to find the area of triangle MRT over the area of triangle MRS. And our height is perpendicular to the base of this triangle MRT. Our height is still perpendicular to the base SR for MRS. Therefore, we can find the area, the ratio of the two triangles. Therefore, area of triangle MRT is equals to half. Our base for MRT is TR times our height, which is that, over the area of triangle MRS, which is over half. The area of triangle MRS obviously is equals to our base is SR. You can see the base of this triangle is SR multiplied by the height. They have the same height. This triangle and this triangle have the same height H. Therefore, this becomes TR over SR. Since this cancels with that and this cancels with that. Now we know that SR is 2 times TR. This whole line is twice this line, is 2 times TR. Therefore, here we're going to have TR over our SR is the same as 2 times TR, 2 times TR. Therefore, we can see that this can cancel with that. Therefore, the ratio of the area of triangle MRT over the area of triangle MRS is equals to half. So this just simply means that the area of this triangle over the area of this triangle is half. That's what it means. Now, since we have got our A, now we need to find a B. In B, we are told that we must find the area of triangle MRT, the area of triangle MRT over the area of the parallelogram PQRS. We want the area of this triangle over the area of this parallelogram. That's what they want us to do there. Now, I'd like to erase here. Now, with B, we are told to find the area of triangle MRT, the area of triangle MRT, over the area of the parallelogram PQRS. Now, for us to find the ratio of the area of MRT over the area of the parallelogram, if we want to find this ratio, we need to first compare this triangle and this triangle. Now, that is why I have constructed a height for this triangle there, which has a height of K, which is perpendicular to the base, and the height of this triangle now, since I'm comparing this triangle and this triangle, I'm using my height as K. Since I've constructed the height outside, since this is obtuse angle triangle, then I know that my base for this triangle here is going to be MS. Now, I'm comparing this triangle with this triangle. Since I only know that the area, the ratio of the area of this triangle over the area of this triangle, I know that it is half. But I don't know the ratio of this triangle over this triangle. I don't know the ratio of that triangle. But if I can first compare this triangle and this triangle, then that's our starting point. Now, for us to get the ratio of B, we're going to start by comparing the area of triangle MRS, which is equals to half. Our base is SM, our height is K, over the area of triangle MQR, which is equals to our height times, obviously, the area of this triangle, its base is MQ, times its height is K, which is equals to 1. Because this cancels with that, this cancels with that. SM is equals to MQ. SM is equals to MQ. That is why we say area of triangle MRS over the area of triangle MQR is equals to 1. Our reason is that we've got equal bases. This base is equals to the base of this. The base of this triangle is equals to the base of this triangle. That is why we say equal bases. The reason why we say this is equals to 1. There was no need for me to get there. I just needed to say this is equals to 1. Then I explained that equal bases. Since they've got equal bases, it means also they've got equal heights, then same height. Then we know that the two are equal. Therefore, it means that the area, therefore, area of triangle MRS is equals to area of triangle MQR. So it means that the area here is equals to the area here. Since the ratio of the area of this triangle over the area of this triangle is half, it also means that the ratio of the area of this triangle over this triangle is half as well. Because these two triangles are equal. This triangle, I've just shown you that it is equals to this triangle. Since the ratio of the area of this triangle over this triangle, it is half, it means that the ratio of the area of this triangle over the area of this triangle is also going to be half. Therefore, area of triangle, therefore the area of triangle MRT over the area of triangle SQR is equals to the area of triangle MRT, which is this area, over the area here. So it means that I can have 4 of these triangles because the area of this triangle over the area of this triangle is half. Even the area of this triangle over the area of this triangle is half. Therefore, the area of this triangle over the area of this triangle is 1/4. I'm not sure if I am clear, but I need to be clear because I have just compared the two triangles to be equal. And if the two triangles are equal, it means that the area of this triangle over the area of this triangle is half. Therefore, even the area of this triangle over the area of the triangle is half. Then it means I've got this triangle, 2 of these triangles here and here, 2 of these triangles in this triangle. So this triangle is 4 times. Therefore, that is why the ratio of this triangle is 1/4. Now, for us to find the area of triangle MRT over the whole parallelogram, we know that triangle SRQ, we know that triangle SRQ is equal to triangle QPS. QPS. Why is that? Diagonals of a parallelogram bisects the parallelogram. Diagonals of parallelogram bisects the parallelogram. If the diagonal bisects the parallelogram, it means that the area of this triangle is equal to the area of that triangle there. Since the area of this triangle is equal to the area of this triangle, and we know that the ratio of the area of this triangle over this triangle is 1/4, so it means that there's 4 of these triangles here. So it means that there's 4 of these triangles also, there's 4 of these triangles also here. Therefore, area of triangle MRT over area of triangle PQRS. Because there's 8 of these triangles, it means in PQRS. Therefore, it's going to be 1, over 8. Let's explain for the last time. We are saying that since we have compared that the area here over the area there is equals to 1, it means that the area here is equals to the area there. And since we found that the ratio of the area of this triangle over the ratio of, or over the area of this triangle is half. And since this triangle is equals to this triangle, it means that the ratio of the area of this triangle over this triangle is half as well. Therefore, it means that I've got 4 of these triangles in this triangle. Therefore, that is why I have the area of triangle MRT over this triangle here is 1 over 4. Now, since the area of this triangle is equals to the area of this triangle, we know the diagonals of parallelogram bisects the parallelogram. They bisects the area of the parallelogram. Therefore, the area here is equals to the area there. Therefore, since the area here is equals to the area there, and we know that this triangle is 4 times here, it's 4 times here, it means that even here it is 4 times. So it means that this triangle, in the whole of this, it is 8 times. Therefore, that is why we say the area of triangle MRT over the area of the whole parallelogram, since the area of this over this is 1 over 4, it means that it will be 1 over 8. Let's look at another example. In this diagram, KL is parallel to OM. KO is parallel to LP. And KP is parallel to LM. We are told to determine or to show that the area of triangle, to prove that area of triangle KTO is equal to the area of triangle KTM. So we are to prove that the area of triangle KTO, KTO. This triangle here, I'm going to highlight it. This triangle here, KTO. This triangle here, KT. We are told to show that this triangle here is equals to LTM, triangle LTM, triangle LTM. So we are told to show that this triangle is equals to also this triangle, which I'm highlighting there. So we are told to prove that this triangle, which is KTO, is equals the area of this triangle is equals to the area of this triangle. We are told to prove that. And for us to prove that, we can use, I'm just going to use the red. We are going to use this triangle, which I'm going to highlight it in red. We're going to use this triangle. We're going to use this triangle. We're also going to use this triangle, which also I'm highlighting in red. So we're going to use this triangle and this triangle to prove that this triangle is equals to that triangle there. Now, this is how we go about doing that. We're going to say area of triangle KOM is equals to the area of triangle LMO is equals to, I'm just going to write it here, let me just, area of triangle KOM is equals to the area of triangle LOM. Why is that? We are still on geometry, we still need reasons. We say that this is equals to this, the area of this triangle is equals to the area of this triangle. Why is that? It is because they are in the same parallel lines. The two triangles are in the same parallel lines. It means that they have the same height. They have same height, same base. You can see that the base of this triangle is OM. Also, the base of this triangle, which is LMO, is OM. Therefore, they've got same height because they are between two parallel lines. They've got the same height. Then they also have the same base. That is why this triangle is equals to that triangle there. Now, since this triangle is equals to this triangle, if I subtract this triangle from this triangle, you can see this triangle minus this triangle, this one here. I'm just going to highlight it using this triangle there. So I'm saying this triangle minus this triangle. I'm going to be left with this triangle. You can see that. Therefore, we're saying that area of triangle KOM minus the area of triangle TOM is equals to the area of triangle LOM minus area of triangle TOM, still the same triangle, TOM. This minus this angle, this triangle, sorry, we get this triangle. We get this triangle. This triangle minus the very same triangle, we get this triangle there. Because from this triangle, if I remove this triangle, I'm left with this triangle there. Therefore, area of KTO is equals to the area of triangle TM. Let's repeat this. We have used this area and this area to show that this area is equals to this area there. Now, we have said that this area is equals to this area. Why? Since they've got the same height and same base. Same base OM. Since these two triangles are equal, if I take this triangle minus this triangle, I get this triangle, which is KTO. KTO. When I say this triangle, which is there, this triangle minus this triangle, I get this triangle. That is why I have that. Equals to this triangle minus the same triangle, which is this one, TOM. I'm hoping that you can see triangle TOM there. Therefore, this minus that will give this triangle there. That is why the two triangles are equal. we have proven that triangle KTO is equals to triangle TLM. Now, for B, we want to prove that area of triangle PRO, the area of this triangle, is equals to the area of this triangle, which is PSM. Therefore, they want us to show that the area of this triangle, I'm just going to highlight it like this, is equal to the area of this triangle. The area of this triangle, we want to prove that it is equal to the area of that triangle. And for us to prove that, we are going to use the parallelogram. We are also going to use this parallelogram there. Now, KLPO is a parallelogram. KLPO is a parallelogram. Why is it a parallelogram? Sides are parallel. Opposite sides of a parallelogram. Opposite sides of parallelogram. Because we know if sides are parallel, then we know that quadrilateral is a parallelogram. Now, we want to make sure that since this is a parallelogram, we know that this KR, I think it's R there, KR is equals to RP. KR is equals to RP. We know in a parallelogram, diagonals bisect each other. There, it's a parallelogram. Diagonals bisect each other. Therefore, it means that this is equals to that. Therefore, that is why we say KR is equals to RP. Reason, diagonals bisects each other. Now, we know that R triangle ROP, we know that the area of triangle ROP is equals to, the area is equals to the area of triangle KOP. Why? This area of this triangle is equals to the area of this triangle, because they've got the same height and equal bases. The base of this triangle is that. The base of this triangle is that. Therefore, equal bases, same height. That is why this triangle is equals to this triangle there. Equal, let's write with another color. Equal bases, bases, same height. That is why the two are equal. Therefore, we know that since this is equals to that, it means that the area of triangle ROP is equals to half the area of this. This area is half the area of this. Since they are equal, these two triangles, the area of this is half the area of that, which is equals to the area of triangle PRO is equals to half the area of triangle half the area of triangle KOP, which is equals to half, obviously this is half this. It is also equals to half of that. It is also equals to half of that, which is also equals to half the area of triangle KPL. Reason why we're saying that? Diagonals of parallelogram bisects parallelogram. Now, we have just shown that the area of triangle ROP, or the area of triangle PRO, however, whether it's ROP or PRO, one and the same thing, we have just shown that this area is equals to half the area of this, which is also equals to half the area of that. If we can prove that the area of this is equals to half the area of that, which is equals to half the area of that, then we have proved that the two are equal. Now, we are going to continue from here. This is our first step of proving B. Our second step, we need to now find a triangle PSM. You find it, which it's a follow-up from what I'm erasing here. It's a follow-up. Now we say KLMP is a parallelogram. Why? Because we know that opposite sides are parallel. Now, we know that since KLMP is a parallelogram where opposite sides are parallel, it means that since this is a parallelogram, it means that diagonals bisect each other. Therefore, it means that PS is equals to SL. Why? Diagonals bisect each other. Now, since diagonals bisect each other, since this is equals to that, it means that this area of triangle PSM is equals to the area of triangle LSM. Why are we saying that? It is because they've got equal, you can see equal basis. Since diagonals bisect each other, since we've just said it, that PS is equals to SL, therefore it means that their height is the same, their bases are equal. Equal basis and same height. Same height. Now, since they've got equal basis and the same height, therefore it means that this triangle is equals to that triangle, which this triangle, which is area of triangle PSM, is equals to half the area of, is equals to half the area of triangle LPM, which is also, this is half that, which is also half that. Since diagonals bisect the area of a parallelogram, this diagonal bisects the area, so the area here is equals to the area there. Therefore, that is why we say this triangle is half of this triangle, which is this triangle is also half of this triangle, since these two triangles are equal. Therefore, it is also half the area of triangle KLM. Since even here, it's still half the area of triangle KLM, this triangle is half the area of triangle KLM. Therefore, it means that the area of triangle PSM is equals to the area of triangle PRO, since we got that this is equals to half the area of this is equals to again half the area of that, and we just found that this area is half the area of this and also half the area of that. Therefore, it means that this, the area of triangle PSM, is equals to the area of triangle PRO. This is a continuation from what I've just erased to show that when this is half of this, also half of that, also this is half of this, and it is also half of that. Therefore, it means that this triangle, the area of this triangle, is equals to the area of that triangle. I hope that I'm clear with this example.